Hello, everybody. It's Mr. Thrasher. I hope you're doing well. Good morning, or maybe good afternoon, or good evening. We are continuing our online learning. So just like before, I have a video that you are going to watch, and then there might be some questions that pop up based on what we are going over. Let's remember that we are in a new unit. We're trying to learn what these stars are made of. When you look out at the night sky and you see these stars, what make them? And how do scientists know what make them? Because they're really far away. So how do we know? To do that, we're going to look at our sun because our sun is a type of star. But to do that, we need to study light. And to do that, we need to study waves. So that's the unit we're on right now. We're learning about waves to understand our sun, and then we're going to learn a little bit about atoms as well. Remember, I still want us to practice doing some writing. So I recommend if you have like binder paper, that'd be fantastic. If you just have a piece of scratch paper, that's okay too. But write down day 3. And I have a question. Let's practice writing our sentences. Our what do you think says are water waves. And I have a picture right here. Sorry, I'm in the way a little bit. Oh my gosh. And I have a nice video diagram right here. Are water waves transverse or longitudinal? Do you remember what those two mean? What do you think? And I want a full sentence. I think water waves are transverse because, and give me a reason. Or I think water waves are longitudinal because I want a full sentence. Try and do that. Now, it turns out that water waves are difficult. If you said transverse, because those waves go up and down and up and down and up and down, nice. Water waves definitely have that up and down, up and down, up and down motion. That's transverse. If you said longitudinal, remember longitudinal is like this, side to side. That's also a little bit right. Water waves are different. They're kind of a combination. They're the two types, transverse and water. Because look at this. Imagine this is like a boat on the water. The boat goes up and down, but it also goes right and left, back and forth. So it's a little difficult. It's actually both. Water waves are both types, but we're just going to look at the two because that's easier. Okay, transverse and longitudinal. Okay, good job practicing. For this video, we are adding to our wave vocabulary. We already learned some wave vocabulary. Now, before you watch this video in the live agenda, there is a link to this document. If you have a printer and you could print out this paper, it's this paper that's on the screen. Fantastic. This has our vocabulary. If you do not have a printer, well, that's okay. Mr. Thrasher has an example. I just got a piece of binder paper and I just wrote down the same thing. Wave vocabulary, wave amplitude will have the same words. So if you could not print it out, that's okay. But let's write out our definitions because you'll need to know these definitions for the rest of this unit. And so when Mr. Thrasher later says calculate the amplitude, you don't want to be like, oh my gosh, what's amplitude? You want to have the notes. So either print out this paper, it is on Canvas, or just get a piece of paper and write down our definitions for physics. We saw this slide the other day. You should hit pause. Hit pause so you can write down these definitions. Easy. Just copy it, screen it. A wave is up and down or back and forth motion that moves energy. Transverse waves, those are the up and down. Longitudinal are back and forth, back and forth. Wavelength is how long the wave is, and amplitude is how tall it is. Hit pause and write down these definitions. Okay? Let's remember how to measure wavelength and amplitude. For wavelength, remember it's the top to the top. It looks kind of like a mountain. So Mr. Thrasher says you measure from mountain to mountain. That's the wavelength, mountain to mountain. Okay, you could go from the bottom to the bottom. That's possible. But I think this one's the easiest. From the top to the top. Okay, from top to top. That's wavelength. And then amplitude, that's how tall, but a little more difficult. Amplitude is measured from this middle line. You see this line in the middle? It's from the middle to the top. Amplitude is not from the bottom to the top. Okay, let's remember that. Now, Mr. Thrasher has our PhET simulator shown on the screen. Mr. Thrasher has a question for you. Were you paying attention? What is the wavelength of this wave? The wavelength of the wave is about 4 centimeters, because here's the top, and here's where Mr. Thrasher has the meter stick. 0 centimeters to, where's one wavelength? Right here, that's 4. 4 centimeters is the wavelength of this wave. I have another question. What is the amplitude of this wave? The amplitude. The amplitude is a little more difficult. Remember, it is not bottom to top. It is from the middle to the top, the middle to the top. Mr. Thrasher has the ruler. Here's 0 at the middle. What's the amplitude? It's less than 1. 1 is right here. So it's a little less. I don't know, maybe 0.8 approximately. But it's not 2. It's not 0. It's a little smaller than 1, about 0.8. If you got those two correct, good job. Let's add on to our wave vocabulary. Our new word is frequency. Try saying frequency. I know maybe you're at home, but try saying it. Frequency. Frequency is how fast a wave goes up and down, up and down. I have 2 pictures here, but look at my hand to start. You could go like this. Okay, I'm going up and down, up and down. Or I could go slower, up and down, up and down. Or I could go faster, up and down, up and down, up and down, up and down. How fast you're going up and down, that's the frequency. It's the frequency going top, bottom, up, down, up, down, up, down. And look right here in blue. If you're going up and down a lot, that's a higher frequency. If you're going slower, that's a lower frequency. Mr. Thrasher has that PhET simulator. Here we go. Here we see the wave. That's a pretty high frequency. Look at that. Up and down, up and down, up and down, up and down. Mr. Thrasher can make the frequency lower. Up and down, up and down. Or Mr. Thrasher can make the frequency, oh my gosh, really big. Up and down, up and down, up and down, up and down. So the frequency is how fast the wave is going up and down, up and down, up and down. So on your paper, whether you printed this out or you're doing it on binder paper, we have a new word, frequency, frequency. How fast a wave goes up and down, up and down. High frequency, you create a lot of waves. Low frequency are smaller waves. Okay, are you ready for your quiz? Were you paying attention? Let's try our quiz. It's not a real quiz, but let's practice. Mr. Thrasher has 4 waves. Wave A, wave B, wave C, wave D. And Mr. Thrasher has three questions. Question 1, what wave has the biggest wavelength? A, B, C, or D? What wave has the biggest wavelength? Wavelength is how long a wave is. Look at A. A is really long. Look, from mountain to mountain. Oh, man. Look at C. Oh, look how much smaller this is. Mountain, mountain. C is much smaller than A. A, B, C, D. A has the biggest wavelength. Okay, amplitude. Which wave has the smallest amplitude? The smallest amplitude, A, B, C, or D? It's D. Remember, amplitude is tall. How tall? D has the smallest tall wave. Ooh, sorry, this gets in the way, but it is D. A has the biggest amplitude. Last one, frequency. Which wave has the smallest frequency? The smallest frequency. This one's difficult. Remember, small frequency, you're going slow, up and down, up and down. Do you think the frequency for D is fast? Or do you think it's slow? D has a really big, a really fast frequency. D is like this, up and down, up and down, up and down, up and down. C is a little slower, up and down, up and down, up and down, up and down, up and down. B is even smaller, up and down, up and down, up and down. A is the right answer. A has the slow frequency, the slowest frequency. How did you do? We should know these terms. We should be able to know what these terms are. Now, Mr. Thrasher has two more definitions. The video is almost over. Two more definitions for you to write down either on your printed paper or on your binder paper. And these two words are damping. Try saying damping. That's like friction. Friction and damping, the same thing. Lamizma, the same thing. And then tension. Tension is how tight. And I looked up the word in Spanish, apretada. It's how tight the material is. For example, here's a piece of paper. Not very tight. The tension is small. But here, a lot more tension. If you're tugging, that's a big tension. If things are loose, small tension. And that's important because, again, on our simulator, let me slow this down a little bit. On our simulator, look right here at the bottom. There's damping. Mr. Thrasher can add friction, damping to the wave. Ooh, look at that. Look what happens. There's friction. Let's put it to 0 friction. And here's tension. We can also change how tight that rope, that string, that cable is. Ooh, here's low tension. Ooh, look at that. Ooh, here's low tension. So we can change those things in that simulation, which we might see again. So you should add those two terms. Damping is friction on a wave. Tension is how tight, apretada, the material is. If you need to hit pause, go ahead. Okay. And that's all Mr. Thrasher has for this video. We just needed to learn a couple more important words about waves. And in our next video, we're going to start thinking about one type of wave, sound waves. Thank you for watching.